The broadcast is now starting. All attendees are in listen-only mode.
Hello, everybody. This is Radzinski. I'm going to be doing the presentation today. We're going to be talking about how to conduct an LCA, or product carbon footprint, to optimize decarbonization of products and operations. And while we're letting people get logged on here for the first few minutes, I'm going to run through a few housekeeping items. So the first thing we're going to be doing, this is going to be a very interactive webinar. We'd like to have lots of people asking questions. We like to have lots of engagement. So if you're new to GoToWebinar, you're going to see on the right is a pane that allows you to put questions in. So at any time during the webinar, please type your questions in there, and we'll be answering those questions. Throughout. At the end of the webinar, we'll be answering the questions, and then we will be answering any questions that we don't get to, as part of the follow-up for this as well. And then in terms of engagement, we will be asking the questions, and you're all going to be muted, so I definitely want you to be typing your answers in the question box as we move forward here. That's going to be the best way to respond to the various questions, because we do have a very interactive exercise at the end of the main presentation, which is going to be really fun, and I'm excited to do. And then in terms of other things we're going to be doing is we will be having some polls, and we're going to be launching these polls throughout the webinar. So when you see a poll pop up, you're going to have the ability to click on the answer and then hit submit, and then your poll will go into a aggregation of the polls for everybody, so we can see what people are thinking about in terms of some of the questions we'll ask in the polls. And just for everyone's information, this webinar will be recorded, and we're going to be distributing that to all registrants within 24 hours. So you don't have to worry about having any issues if you missed something, or you wanted to get more information. You'll definitely be getting this, as well as a lot of support information from our team here. The other thing I would say is, if you have any issues at all with the GoToWebinar, you can definitely communicate through the question box or the chat box, and our team will definitely take care of any challenges you might have. So with that, I'm going to get rolling here, and I see there's a lot of people still signing on, but we can get started. So again, I want to welcome everybody. I'm Radzinski, and I'm the president of Sustainable Solutions Corporation. And just a little bit of background, we at SSC have been doing life cycle assessment now since 2007. We actually started a sustainable solutions company in 2001. We are definitely way ahead of our time when it came to sustainability and doing LCA. When we started in the early years, there was definitely interest in it, but there wasn't the massive requirements that we see now, which is why we're doing this webinar. And one thing I can say is that, doing LCAs in 2007, it was definitely a learning experience, and, trying to figure out what softwares were the best and that kind of thing. And then we actually issued our first EPDs in 2010 and 2011. An EPD is Environmental Product Declaration. And since then, we've done now hundreds of LCAs and EPDs, and now carbon footprints, which is another very popular way of understanding the impacts of a product. And I will say that we have an amazing staff here at Sustainable Solutions Corporation, made up of LCA experts and analysts, and many of our team members are chemical engineers that do this work. So it's really important work that we do, and we're going to talk about that throughout the day here. I also wanted to mention that I have been teaching in a university setting since 1998, and I started teaching sustainability curriculum classes in 2001. I've been teaching at Villanova for over 18 years. And while I was there, I helped create our Master's in Sustainable Engineering program. And in that program, I actually taught the Advanced Lifecycle Assessment and Introduction to Sustainable Product Innovation, as well as a Sustainable Buildings and Operations class. So one thing that our company is really big on is education and teaching, and that's why we're hosting this webinar series, because we know that we have a lot of work to do in society here if we're really going to make some massive changes to minimize the impacts of global warming and climate change and all the other things we're seeing when it comes to sustainability. So that's one of the main reasons we put this whole webinar series together. So today my agenda is I'm going to be talking about market drivers for LCA and PCF. We're going to really understand what is a life cycle assessment and what is a product carbon footprint. Then we're going to talk about how to prepare for doing these. There's a lot of preparation. These are really complex and complicated things to do. It takes a lot of data and a lot of information to really do it. And then we're going to actually do a life cycle thinking exercise. We're going to use a common product, which would be a tire. And we're going to get all of you thinking about how you would think about products and operations. I know that many of you attending may not be manufacturers. Maybe you work for a company where your customers are doing LCAs, or maybe you're an architect, or that kind of thing. So I want to make sure that we get everybody to understand what life cycle thinking really means on common products. So we're going to bring that in as well. So with that, we're going to launch our first poll here. And I want to ask all of you, as you see the poll here, have you or your organization done an LCA or PCF before? So like I said, just go into the poll and click your answers and then hit submit. And we should be getting responses coming in here. Okay, we got a lot of people clicking. We got a bunch of people saying yes, some no. Looks like it's rolling along here. We're going to give it a few more seconds, get more people voting here in the poll. All right. All right, I think we can close the poll. We got about 67% of you, 2/3 of you are saying yes about the poll, and 33% are saying no. So we got some people that are definitely experienced in understanding what LCA and PCF is, and then we have some of you that haven't done it yet. So you're just learning. So I'm going to definitely tailor my presentation today around that. So with that, I'm going to roll now into back to the slides. And we're going to talk about market drivers. So one thing I can tell you is, like I said, starting doing this service in 2007, we were doing LCAs. There weren't a lot of people asking for these. It was really new. There was a lot of activity around, just starting out in the green building world. But now we're seeing a tremendous amount of customer requests. If any of you are doing scope 3 you're trying to understand your carbon footprint, scope 3 is looking at your supply chain and different categories. That's one area that is a really big topic right now. We're also seeing federal and states and other government agencies, even European Union now has regulations around requiring the understanding of the life cycle impacts of products. And then we're also seeing a lot of activity in green building standards. And one thing I can tell you, we've done this for a long time, and we would never recommend to a company or any organization just to do a life cycle assessment to develop an EPD or a product carbon footprint. We think it's critical that you use this information. You're going to spend all the time and effort to get it together. We think it's critical that you use this information to really think about how you're going to use it for competitive advantage, understanding your environmental impacts and thinking about how you can do things better. We think it's critical for your decarbonization strategies of both your products and operations. And I'm going to show you that today when we look at data that comes out of an LCA on how you can look at that and really use it. And then really, it's a great way to drive continuous improvement. And one thing we're going to be doing is next week, we're going to be doing a webinar on sustainable product innovation, where we're going to take what we learned in the webinar today, and we're going to use it to make our products more sustainable and our operations more sustainable. We're going to work on reducing carbon footprint in products, reducing carbon footprint in operations. So just quick, a couple of these big drivers that you'll see. Gensler is one of the largest architecture firms in the world, and they have a whole initiative now called EC3, GC3, the Gensler Cities Climate Change Challenge, where they're looking at what we call embodied carbon of all the materials that go into a building. And I'm going to explain embodied carbon in a minute. But they're also looking at how to reduce operating carbon, the energy that's used in the building, as much as possible. And then after they do that, they want to try to offset those impacts by using renewable electricity or carbon-free electricity, as well as possibly looking at using carbon offsets. And one thing that Gensler has done is they've analyzed through whole building LCA, whole building life cycle assessment, to understand what materials and building systems typically have the largest impacts. As you can see on this slide, The top 10 are basically the building enclosure and structure. It's made up of steel and concrete and insulation and different things like that, the glass that goes on the building, aluminum, etc. Even carpet made it in the top 10. And then you start to look at other things on here and you're going to see that there's things like glass and tiles and flooring and doors and all kinds of things that are going into a building. And these are all, every one of these things has a life cycle impact when we build a building. So understanding that these materials and looking to select materials that have lower embodied carbon or lower carbon footprint is a way to reduce the initial carbon footprint when you build the building. Also, LEED, which stands for Leadership in Energy and Environmental Design, is a green building standard, and that's driving more sustainable products by requiring or giving the ability for LEED consultants and architects and designers to earn points in achieving a LEED certification by selecting at least 20 different permanently installed products that have environmental product declarations. And you can earn an additional point if you select at least 5 permanently installed products sourced from 3 manufacturers that have reduced their carbon footprint. So that's where we're going to talk more about this next week when we talk about sustainable product innovation. But that's how you use lifecycle to drive down your impacts. Another big area we're seeing a lot of activity right now is with the United States Inflation Reduction Act that came out in 2022. Huge focus on promoting and understanding the life cycle impacts of products, and also looking at carbon labeling. How are we going to basically disclose the carbon footprint of products and select products with the lowest carbon footprint? We're also seeing organizations like Colorado just passed embodied carbon legislation. We're seeing other states like Washington, Oregon, California, New York, New Jersey, Connecticut, Minnesota, all starting to pass legislation where they're going to be looking at requiring environmental product declarations and setting what we call global warming potential limits on products like asphalt, cement, concrete, glass, steel, wood, etc., that would be used in state projects. We also know that in the European Union, the European Green Deal actually is requiring environmental product footprints to be done, which is another way of looking at the life cycle impacts and understanding those impacts of the various products that are used, not only in buildings, but also in consumer products as well. So lots of drivers, and I'm going to tell you right now that this demand for LCA, demand for EPDs, and demand for product carbon footprints are not going to go away. One thing we know for sure is many companies have set science-based targets, and they're actually setting goals to basically become net zero carbon, net zero impact from a carbon footprint perspective and greenhouse gases. And what they're finding is they can definitely do work on their own scope 1 and scope 2 emissions, which is the fuels and energy they use, but they're finding that a huge percentage of their impact is driven by their suppliers. And what I'm showing you here are the various categories that are listed under the scope 3 in the greenhouse gas protocols. And you can see purchased goods and services is listed here in green. If any of you on this call are a supplier to a manufacturer of some end product, then they're going to be coming to you and saying, we need to understand your impacts of your products and your impacts of your operations so we can better measure and better figure out how we're going to reduce our own scope 3 emissions. And I'm going to tell you more about that, but that's a huge driver we're seeing right now. So now we have another poll. And I want, if you can ask, the question here is, are your customers requiring you to provide an EPD or product carbon footprint? The simple answer, yes or no, please go into the poll. We're seeing a lot of activity already, a lot saying yes, some saying no. And we got about 46% of you that have voted, 16 seconds. We're going to give it another few seconds here, keep voting. Really appreciate everybody participating. This is what makes these exciting. Instead of just looking at a screen, we're getting you to interact. All right, keep going. We're going to try to get at least 70% voted. We're almost there. Got about 63%. All right, we can close that poll right now. So if we look at the results, we can see that about 58% of you are saying your customers are requiring you to provide an EPD or PCF. So your customer could be, if they're a major person that's selecting your raw materials or end products that you make, or it's basically an architect or designer, or even a government organization. So great, thank you for participating in that poll. So now let's dive into life cycle assessment. And a life cycle assessment is basically a study of a products or operation or different aspects of many things we can look at across a product, a process, or an activity over its entire lifespan. So that would mean we're looking at basically what we call the life cycle stages of a product. And the biggest one is the extraction and processing of raw materials. We're going to talk a lot about that today. Then we have to transport those raw materials to some plant that manufactures something. And then after the manufacturing is done, those products that are made get distributed out to the world. Then we install them, we use them, we maintain them. And then at the end of life, they get disposed of or recycled. So it's shown as a circular process, but if we are disposing of things, we're actually losing those materials. If we're closing the loop and going circular, we're recovering them back possibly. So again, five major stages. We're going to talk about that a lot today. And I do want to say that when we do life cycle assessment, it is governed by at least, these two primary standards, ISO 14040, that's International Standards Organization 14040 and 44. And that basically dictates how we do life cycle assessment. And then basically life cycle is done in 4 key phases. Okay, so first thing we're going to do is set our goal and scope definition. And what we do there is we identify the goal of the study. We look at our system boundaries. I'm going to talk more about that in a second. And then we talk about what is the functional unit. We define what the functional unit is. A functional unit could be, if you're a supplier of a raw material or a chemical, you might be, providing a functional unit of 1 kilogram of material. Or if you're a manufacturer, say, of siding or roofing or something like that, your functional unit will be in terms of area, like 100 square feet or square meters. If you are a wire and cable manufacturer making pipe, it might be in length, like 100 feet of cable or 100 feet of pipe. And I'll show you some examples of that in a minute. The next thing we're going to do, and I'm going to talk about that in a few minutes, is life cycle inventory. We're going to collect data, lots of data, and we're going to basically develop a process flow diagram or a material flow diagram. We're going to try to understand how these products are made, getting down to every material and every ingredient, every input and output into the process. Then what we do in the next phase is doing life cycle impact assessment. We use life cycle software to do that, typically SimiPro or Gabby, to do those analyses. And then we interpret the results, and it's definitely an iterative process. We have to go back and forth, and we need to understand the results. Do they make sense, and things like that. So when I mentioned system boundaries, when I'm talking about cradle to gate today, this is basically when we mentioned the term embodied carbon. Cradle to gate is typically the raw material extraction and processing, the raw material transport, and then the manufacturing of a product. It could include packaging. If you're required to do a product carbon footprint by one of your customers, this typically is what's going to apply to you if you're a supplier. So if you're supplying a chemical or a raw material, your end manufacturer is going to ask you to maybe do just the cradle to gate, because you're then sending those materials off to them to do the final manufacturing. So this is definitely something that gets dictated here. The other thing that's going to dictate what the boundaries will be is going to be your customer. It's going to be what we call a product category rule, which I'll talk about in a minute. Or it could be what your goal of the study is. If you're using this to do a life cycle assessment to understand your internal impacts, and you're not going to disclose it externally, you may only do, cradle to gate. But if you want to go full LCA, you may go cradle to grave and look at the entire life cycle. That would include distribution, use, installation, maintenance, end of life. So imagine this, a simple example of this would be, if I'm looking at my product of paper, this might be, I'm going to extract trees out of a forest. There's all the steps that go into that extraction and, getting the trees there, transporting them to the manufacturer, who then makes them into a pulp and then eventually makes them into a paper. That would be the different steps you would think about from cradle to gate. And then when they come out to us, the users, if we use that paper, we use it one time, and then what do we do at the end of life? So that's a good example to see how this is working. So definitely want to be thinking about what the LCA tells us. Like I said, in stage 3, we take all that information, we run it through some LCA software, and what we're going to understand then is what the potential environmental impacts are. So the big one that we're going to be talking about today that everybody's focused on would be embodied carbon, global warming potential, carbon footprint. These are all terms you'll hear. And this is basically looking at, climate change impacts that measures all greenhouse gases in terms of what we call kilograms of CO2 equivalent. So kilograms of carbon dioxide equivalent. So even if we're looking at methane or other gases that might come out of that process I just showed you from the life cycle, we're going to be looking at this from the GWP or global warming potential perspective. As you can see here, there are other impact categories we can look at, like things like acidification or ozone depletion, fossil fuel depletion. Now, these do get measured in a full LCA, but in a product carbon footprint, you're not going to be looking at these other impact categories. You're going to be focused on global warming potential only. And I also want to point out that when we do LCA, our software allows us to also look at things like carcinogens and ecotoxicity and things like that. But those results have a lot of uncertainty, and we typically don't do much with those. We can analyze them, but we're not doing a lot with them. So big topic today will be global warming potential as we go through. Now, when I'm also talking about scopes, I want to set the stage here. When we talk about various greenhouse gas emission sources, I'm going to be talking about scope 1. This is basically the fuels we burn directly in an operation. It could be in vehicles, it could be in a manufacturing plant. It's the fuels we burn in our home if we're heating water or if we're heating our homes. Scope 2 is going to be the fuels we buy or the energy we buy. So like electricity. Most of us do not generate our own electricity. Most companies don't generate their own electricity. They're buying it from an electric utility. So the electric utility is basically the one who is creating the direct emissions of burning something. If they're using coal or oil or natural gas, or maybe they're using it's hydro, or maybe it's wind turbines or whatever. But the scope 2 emissions, the greenhouse gas emissions that from the electricity we use, is associated with scope 2. So when we're looking at our own operation, we will understand our scope 1 and 2. But then, like I said, scope 3 is a big deal. So we want to understand, what are our suppliers? We're responsible for buying things from our suppliers. We're also responsible for, solid waste management and all kinds of other things, but we don't directly control that. So these are beyond our control. So basically what we have to do then is, if we want to understand our true carbon footprint to meet science-based targets and the greenhouse gas protocols and all kinds of things, then we need to understand our suppliers' scope 1 and 2 emissions become our scope 3. Okay, so that's basically how this works. So one thing that I'm going to talk about a few things here, but I want to show you, you're probably saying, well, what the heck does an LCA even look like? So first of all, I want to say that LCA reports are typically not disclosed publicly in many cases. When we do a life cycle assessment, for the majority of them, this is like an LCA report gets generated, it gets kept within the organization and typically not made public. However, there are cases where there will be organizations that want to make their life cycle assessment public. And in this case, this was done, a study that we did for Unibel, which is the PVC Pipe Association. And they wanted to be very transparent about the life cycle impact of PVC for water and sewer pipe, and also look at other pipe materials out there. So this one you can find publicly, which is why I'm showing it to you. But I would say the majority of what we do when we do LCAs, there's a lot of proprietary information. There's a lot of secret stuff in those. We don't want to be putting them out publicly, which is why most companies are going to do an environmental product declaration or a product carbon footprint. So some things you might see in an LCA would be information about all the life cycle stages. This is showing basically the embodied energy or cumulative energy demand across the life cycle. Notice we have installation, we have raw materials transport, we have manufacturing listed here. And this is measured in megajoules per 100 feet of pipe. Our functional unit here is 100 feet of pipe. But then if we wanted to look at the overall cradle to through installation life cycle greenhouse gas emissions, so this would be like basically the carbon footprint. You can see here we would look at all the stages, and by far raw materials has the biggest impact here. 680 kilograms of CO2 equivalent per 100 feet of pipe is coming from raw materials for this particular 8-inch pipe. The total is 960, with installation being a huge driver. So this is the kind of information we get from an LCA report. The other thing I wanted to talk about today is a thing called a product category rule. A PCR basically provides the rules and requirements and guidelines if we're going to run or develop an EPD for a specific product category. So that pipe I showed you there, when we did that, there's also an EPD that goes along with the PVC pipe. And we had to follow a product category rule to do the life cycle assessment and also to publish an EPD in addition to that life cycle assessment report. It's based on ISO 14025, and PCRs are typically developed by what we call program operators, UL Environment, NSF, EPD International, EBU. These are all different organizations that would create a PCR. It's usually a whole group of individuals coming together to develop a specific set of rules, which is going to allow us to measure like the impacts of a product in a fair manner, right? So if I want to look at PVC pipe, but I also want to look at ductile iron pipe, or I want to look at HDPE pipe, if those organizations also did LCAs, they would follow the same product category rules. So we're all looking at the same functional unit, same system boundaries, same impact categories, et cetera, to make a fair analysis so we can look at these in a manner. These are typically not recommended for direct comparison, but it's just meant to identify and do these LCAs and EPDs in a fair manner. They're usually valid for 5 years, and they're typically developed for building and construction materials. So once we're moving forward on a project, we know that we're going to do a life cycle assessment. We're definitely going to be following the international standard of ISO 14040 and 44. We're also going to be following 1425. But if we're going to be doing an EPD, which is a great way to disclose the environmental impacts of a product without disclosing your proprietary information that's in your LCA report, these things really are good for promoting, good transparency. There's an example of one you can see here from marker board and tack board. This is one that we did a while ago. The functional unit of that would be the actual tack board. And then we look at this, and we also have to follow, in addition to ISO 14025, the PCR for this particular product required that we also follow ISO 21930 and EN 15804. So that's a European standard because this is going to be shared in Europe as well. And that sets up a whole bunch of different rules on how we run the LCA. And these LCAs and EPDs, once you're going for an EPD, are going to be critically reviewed by a program operator. They're good for 5 years. And these are really not supposed to be for comparative claims, against industry competitors. The PCR sets a fair way of doing it, but you're not supposed to really be using these for comparisons, direct comparisons. So now I'm going to talk quickly about product carbon footprint. So a PCF, what is it? Well, you follow an LCA methodology, but you're only looking at the global warming potential of the actual product. So it's important to note, I showed you those other impact categories, acidification, ozone depletion. When I'm running my LCA, I'm really looking at full impact of the product across all those different impact categories. But for a product carbon footprint, just zooming in on what we call climate change, the carbon footprint, the global warming potential. So it's the greenhouse gas emissions that are associated with the product. PCF definitely follows the base of ISO 14040 and 44, but the dictating standard is really ISO 14067, and that is what guides us on how we do a product carbon footprint. We also follow the greenhouse gas protocols on how we measure various emissions and allocations, how we treat renewable energy, how we look at different things. If you are a manufacturer, say, of a raw material and you make a chemical or something that goes into an end product, your declared unit might be 1 kilogram of a product. That might be what your customer is asking you to do. Or you could do a full product like this example we show here of a Dell Precision Tower that's showing 1,502 kilograms of CO2 equivalent for this product. And they give a plus or minus 211 kilograms of CO2 equivalent because there's various uncertainties as they do this. I will say also that a product carbon footprint is typically critically reviewed by a program operator. So again, PCF has been done for a while, but they're really getting a lot of traction right now. And, like I said here, we've done hundreds of LCAs, we've done many EPDs, hundreds of EPDs, and we're doing quite a few PCFs right now supporting this. So a lot of activity around this. And what's driving this in a big way is in the chemical industry, Together for Sustainability, which is a whole group of chemical manufacturers, they came together and said, we need to put together some specifications for suppliers on how to do product carbon footprint calculations. BASF was a huge driver of this. They developed a very detailed methodology, which then fed into Together for Sustainability and helped them model this. But if you are a supplier to a chemical company, then you're going to want to be looking at these requirements in addition to those standards that I just mentioned. Also, I did want to kind of summarize this. I threw out a lot of acronyms, but if we're really looking at this, the key takeaway here would be that the life cycle assessment is the core for anything you do. That is often not shared publicly. You would also then be looking at a product category rule, if applicable, whether you're doing an EPD or a product carbon footprint. And if you have that, you would then follow that to create these other documents. So just giving you kind of a summary of a bunch of slides that I just showed you there. So now we have a poll, and we're going to give this about 20 seconds or 30 seconds. So the poll says, and this is your opinion, what is the most important step in the development of an LCA or PCF? Is it data collection, identification of the product boundary, availability of a PCR? Again, no right or wrong answer. Take your best guess. And we've got about 23% voted now. So keep filling in your answers there. Appreciate it. This is just to gain a level of understanding of what's required here when we're doing LCA. So what's the biggest thing here? We got 66% voted. Okay, we're going to get to 70, and then we're going to stop the poll. All right, awesome. So about 58% of you have said data collection, 39% said identification of the product boundary, and 4% said availability of PCR. I would say the correct answer is data collection. Very complex process. We're going to dive into that now and how important it is so you all understand how we prepare for an LCA and PCF. So if we think about data collection, like I said, it's a lot of information we got to collect, and we're going in deep, right? So first thing we're going to look at is we're starting at, let's assume this is cradle to gate. So we're going to definitely be thinking about the bills of materials or the product recipe. Very important that we understand that because we have to look at the raw materials and all the ingredients that go in. It's like making a cake. You got to look at everything that went into making that cake, right? The other thing we're going to be asking for is like material safety data sheets, SDS sheets, safety data sheets. We're going to also have to understand where your suppliers are located and how are they transporting those raw materials to you? Because most companies in the world are not actually manufacturing every raw material that goes into their products. The majority of them are buying lots of raw materials, lots of ingredients, lots of materials from others, transporting them and then making them into a product. Then the other thing we have to measure if we're looking at cradle to gate is your production data, energy, water, wastewater, waste, packaging materials, support materials. We need to know a lot of information. If we have to go cradle to grave, then we're going to be looking at what is use phase, how is energy used, what's the maintenance, how do we distribute the products out to the world, what happens at the end of life. So these are all the data things that we have to think about, and this is just an example of some of the things we might collect. If we look at this data collection example, you can see here, I don't know what this product is, but this is probably like a water bottle or something, but if you look at it, polypropylene, the paper, the adhesive, the labels, we need to know that information. We need to know how much of it went into the product, either in mass percent or total mass. What are the units? Where did it come from? How was it shipped? Then if we go into your actually manufacturing stage, then and this might be coming from your suppliers, some of this information, we're trying to get this information. Then for production, that's your manufacturing stage. We're going to try to understand how much did you actually produce? Because to get our functional unit, we have to divide that information by the total production. Another thing we're going to be looking at is energy, electricity, steam, natural gas, fuels, this is the purchased electricity. This is the basically the fuels you burn. And then we're going to want to know, what are the units? What's the total quantity in a year? And this is going to be based on how you manufacture things. So again, how did it get delivered? Did it come from a pipeline? Was it delivered by a truck? Because we have to factor all of these steps into the LCA in order to do the EPD or the PCF. This slide is great. This just shows you that if you're getting ready to do this, you don't do this on your own typically. You're going to be working with a team. Typically, if we're working with a company, we're going to work with a project manager at the company. Then they're going to be tapping into all these different folks. Your environmental health and safety team, your marketing or product manager is going to know a lot about the product. You might go to the procurement team and ask them, hey, we need the bill of materials or we need supplier information. How is this stuff getting transported? For a lot of that manufacturing data, you might be working with your operations manager or process engineer. Or maybe you're going to want to run some what if scenarios. That's the beauty of doing LCA. You can basically do your baseline and understand where you are. And then if you're doing new product development, you want to run a few what ifs, like what if we change the material or what if we change the manufacturing process? Your R&D team might have input to that. So you're really going to rely on people in a big way to help you get all this data. And this step makes or breaks the schedule. The more we can be organized, the more you can pull all this data together, the better for us to put this together. Or even if you're doing this internally yourself, you're going to need to get all this information. I do want to take 2 minutes here and talk about data quality. This is really important. The quality of the LCA is going to be dictated about the data that we utilize. And we look at two types of data. Primary data is going to be data that we get directly from a manufacturing operation. That would be measured data. Typically, we can get meter data on electricity or natural gas use, or we're going to get an actual bill of material with real weights or mass percent, or we're going to have measured emissions coming out of that factory or operation. And then the other source of data would be secondary data. That's usually coming from sources other than direct measurement. So we're going to get that from our LCA databases like EcoInvent, US LCI, Gabi, or published literature or national databases. Our goal in life is to try to get as much primary data as possible. And this is why many of you are being asked to do product carbon footprints, because right now, if I'm a manufacturer of a product and you're a supplier to me, and I don't have you don't have an LCA, I have to get a secondary data source based on the material you're selling me or the chemical, which is good, but it's not great because it's not exactly what you do as my supplier. So when you're being asked to do your product carbon footprint, that's the reason, because we want to get as much primary data going forward. Allocation is a really important step here, and this is how it gets really complicated. Let's say you're a manufacturer that you make 50 different products in your plant, but you're only looking at one of those products that you're going to do a product carbon footprint on or an LCA. You got to figure out how to allocate that 20 million kilowatt hours that you use in a year to that one particular product, or the natural gas you used, or the water, or even the raw materials. How do you account for that one product? That's what allocation means. And there's very strict rules in the ISO standards. There's also very strict rules with how product carbon footprint's done based on ISO 14067, as well as the Together for Sustainability guidelines on how you do this. That's why I want to mention this. And this is where having a lot of experience and having experts do this work is really important. I do want to tie this back to suppliers and how important it is with the supply chain. Like we talked earlier about scope 3, right? There's 15 categories when we're looking at scope 3, and many of you on this call are probably trying to figure out how to measure your scope 3. And what you're going to see here is 11 out of the 15 categories in scope 3 we can measure using lifecycle assessment. This is why LCA is so important in decarbonization and understanding impacts. When we do scope 3 work here, we're using our LCA tools and our databases and everything else when we are helping companies do their hotspot analysis to understand what categories are most relevant, and then to actually quantify what those really look like. Like I said, purchase goods and services is a big one. If you are a company that makes something and is sourcing from a lot of suppliers. The other thing to point out here is when we're thinking about doing our LCA, we're coming back to our boundary diagram. If I'm doing cradle to gate and I'm a manufacturer making a final product, everything in white here is my suppliers. I usually I'm buying from multiple suppliers to get my raw materials. And then that supplier is buying multiple things from suppliers. So this chain gets bigger and bigger. The materials getting to my plant is probably contracted by that supplier to get it to my plant. So that's another supplier. So this is where this all connects. The scope 3 thing is huge and it's really big. Everything in green is probably the direct thing. So if I'm doing an LCA for a company that makes a final product, we're really getting primary data from them here. And then going forward, you know, we're really relying on secondary data or trying to get actual LCAs, EPD, not LCAs, but we're going to get fact sheets or PCFs or EPDs from some of these suppliers to help us do our full LCA for the final product. So now I showed you LCA results before from that Unibel report. Now I want to show you this example. This is what comes out of our software, looking at the life cycle stages. Raw materials is blue, red is raw material transport, manufacturing is green, and then packaging is purple. So if you look at this, and you can see here, I can look at global warming potential. I could see what the size of these bars in percent is what the percent impact is. So you can see these 3 stages are pretty big. And then packaging is pretty big as well. So if I look at my other impact categories, I could get data on this as well. And I can look at, you know, we want to look at this holistically if we're doing a full LCA and doing an EPD. But if I'm doing a product carbon footprint, I'm only going to be zooming in on the GWP, the global warming. So if I do this, I click and I blow this up and I say, all right, where is this data being driven? Energy use is a huge driver in LCA and carbon footprint impacts for GWP. If you're using electricity, fuels, etc. So my manufacturing plant, scope 1 and scope 2, I can see what my impact is here. It's probably almost 20% of the impact of the product, maybe 18%. Supplier emissions for the transportation of those raw materials to my plant is only, you know, a small percentage. And then the supplier emissions of those raw materials is huge. And then if I throw in packaging, I suddenly got a huge thing. So I need this data. I need to work with my suppliers to understand all this. So this is an example of looking at LCA aspects from the life cycle stage perspective. But then if I look at raw materials, I can run the same analysis about all the raw materials I'm using and saying, what raw material has the biggest impact? I can see here that material 7 has a huge impact, followed by number 2 and number 1. And if I do the same thing and I blow this up, and I'm going to say, all right, I want to figure out how I'm going to reduce my carbon footprint in my product, and I'm working with my suppliers. Number 1, I better go to material 7 supplier and say, look, do you have a PCF or an EPD? I really need your information because this is a huge part of my impact. And I'm also going to say, which we're going to talk a lot more next week, is if I wanted to dive deep on this, what can I do to reduce material 7 in my product and reduce my overall carbon footprint? We're going to talk a lot more about that next week. And I also wanted to go back to this. When I see this, I can say, all right, in my manufacturing stage, I know I can reduce my carbon footprint. If I do what we call a sustainable operations assessment, I can figure out a way to reduce energy use in my plant as well as waste and scrap and everything else, and I'm going to reduce impacts there. So we do have a proven process that we follow. This whole process, if we're going to publish a full critically reviewed EPD or PCF, it could take up to 8 months. However, we can shorten that a lot if we can shrink down the data collection phase. We also know that a screening level, if we just want to do screening levels, we can do these a lot quicker because we're not going through critical review and we're just going to write a full LCA report, et cetera. And we do use tools to help drive this along. So this is our proven process. Now, we've got about a good amount of time here. I'm going to take about 8 minutes here, and I want to run through this tire exercise. And this is where I want you to start typing things into the chat. I'm going to ask you questions. So we're going to think about life cycle thinking. And the first thing we're going to think about here is if I really want to understand sustainability, I got to understand product. So very common product. I'm sure whether you own a car or not, you've ridden in a vehicle at some time in your life. And we see these all the time. So if we were going to be thinking about raw materials extraction, my question to you would be, what is a tire made from? You can start typing this in the chat or right in the chat pane. What is a tire made from? Just go in and start typing in some materials. I'll prime you here. Rubber, right? We definitely think rubber. What else is in a tire? Steel belts. That's great. Fabric, maybe. Petroleum. I'm seeing lots of great answers in here. Thank you. This is great. Keep the interaction going. Love it. Love it. additives, synthetics, electricity, absolutely. So if I click one more and I look at what is a tire made of, and this is not a complete list, but if I had a full bill of materials, these are all the things that could be in a tire. Natural rubber, polyisoprene, styrene, butadiene rubber, silica, carbon black, sulfur, textile fabric, steel, complex organic compounds, et cetera, et cetera. So we look at how is that tire made, and we do a cross section. When we're doing LCA, it's critical to understand what's going into this product. And this is where the data collection really comes in. And we have to get down to every ingredient we can. We could obviously, have cutoff rules where there's some things we just cut out, but we then want to understand what are all the raw materials, how do we run the LCA? So one thing we're going to talk about this a lot more, I'm just going to prime the pump for next week when we do our dive in on sustainable product innovation. Which of these products might be hazardous? Which of these materials, what can we use alternate materials if we want to do sustainable product innovation? Maybe something bio-based, rapidly renewable, recycled content. Are any of these products or chemicals produced as a waste or byproduct in another facility that we could bring into our product? Is there future viability or availability? Is there any risk to us that we have to think about? Like LCA really drives all these great things. And can these materials be recycled? So the next thing I want to talk about is manufacturing. So if we think about this, next stage, we looked at raw material stage, we looked at transportation, now we're talking about manufacturing. So how is a tire made? Just put any thoughts you have in there. What does it take to make a tire? Did you ever think about this? If anybody's here that makes tires, you probably know. But I can't imagine it's an easy process to get this tire. Maybe it's something where we heat it, we make molds, maybe it's injection molded, extruded. And this is where, when we're using our life cycle thinking caps, we want to understand what's going on with this tire. Great answers I'm seeing. Injection molding, lots of heat, trimming, melting and molding, mixing. Awesome. Thank you all. I'm so excited you're putting this in here. Curing process, that's great. Annealing, grinding, exactly. So if we were going to make, this is an example when I said process flow or material flow diagram, when we're doing LCA, we're trying to understand all the inputs here. So we start out with compounding and mixing. We take all the ingredients, we mix them together. We then run them through an extruder and a calendar machine, and we get out the, ingredients of a tire. We have a tire building machine where this is basically, during the extrusion process, we're putting in the belts, we're putting in the steel, we're basically making this tire, we're assembling it. Then we go through a curing process. And I saw a lot of you put heat, lots of energy. That's where the curing comes in, right? Extruding if it's done under heat, absolutely there's energy and a lot of heat going in that. So tires are going to have big impact. And then there's the finishing stage. This is where the grinding and molding that you put in there. And then we have to test them. And what happens when a tire fails the test? It becomes a reject. Or what if we generate a lot of scrap out of these? That's materials we put in, but we got nothing out of. We had to put in all the energy, right? So if we're thinking about manufacturing considerations, can the process be made more efficient? Can we use waste heat out of the process to reduce energy use in this plant? Can we reduce the scrap rate or defect rate? Knowing that curing is one of the most energy intensive processes, can we use other joining systems? Or can we require a shorter or cooler curing? These are other considerations. Like I said, one thing that we provide is a service we call sustainable operations assessments. And the ideal world is when sometimes we do life cycle assessment and sustainable operations assessments for a company at the same time. And while we're doing this, we have one team understanding all the life cycle impacts, and we have another team understanding how they can make changes to reduce energy use, reduce water, reduce waste, save raw materials, and save a lot of money. That's what we do here. And we'll talk more about this next week, but we do have a great download on this if you want to learn more about how you can conquer carbon in your operations. The next thing we're going to think about is use phase. So now we're going cradle to grave on this tire. So another poll, we're going to launch this poll right now. What stage of a tire's life involves the most energy consumption or the most carbon footprint? Manufacturing the tire or use of the tire? Again, no right or wrong answer. Take your best guess. All right, we got about 24% voted. Keep voting here. Is it manufacturing or use of the tire? So far, 66% are manufacturing, 37%. Keep going. We got a 52% voted. Keep going. We're doing great. We're doing great. Gonna get a few more here. All right. All right, let's close the poll. So the correct answer is, from a life cycle perspective, 63% of you said manufacturing and 37% use of the tire. That's great. The real answer, or the correct answer, would be use of the tire, and let me tell you why. So if we look at product use in the manufacturing stage, the average tire, and this is energy measured of total energy in megajoules, takes about 1,036 megajoules per tire to make a tire. That includes the raw materials and the manufacturing and everything else. Then I look at the use phase. Think about it. If I put a tire on a car, number one, I'm going to put 4 of them on there, or more if it's a big truck or something. And then during the life of the tire, I'm going to be driving that vehicle, and the tire has a direct effect on the energy consumption of the vehicle. So basically, use phase, over the lifetime, if a tire gets 60,000 miles, it lasts for 60,000 miles or 80,000 miles, 51,155 megajoules of energy, gasoline, diesel, fuel, is attributed to the use of that tire. And we do know tires do have a big effect on the overall miles per gallon we get out of a vehicle. We can, if the tires are improperly inflated, it's going to increase our energy use. If there's air leaks, all different things. So we need to think about, when we're designing any product, we have to consider if there's a use phase, that could be the biggest phase. So what companies might do here is make decisions to make their tires last longer, or to fill them with nitrogen, or different things like that. So now let's talk about end of life, and then we're going to go into questions. So typical end of life, about 280 million tires are discarded every year in the United States. Only 30 million of those tires are retreaded or reused. That leaves about 250 million that go to waste. That's unbelievable. Working at EPA for 10 years as a waste minimization national expert, I saw this as a huge problem. 54% are burned for fuel. Some are ground up. So we have to think about, what can we do different at the end of life of a tire? We're going to do an exercise next week, come back to this tire exercise and think about what would we do different. Now, I do know, can we think about end of life? Can we design this for easy recycling? Can it be retreaded? Can we have a take-back program? Are there alternate uses? Here's 2 examples of 2 companies that our sister company, Green Circle, certifies. A company called Pretread takes tires and makes roadway barriers out of them and uses lots of tires instead of disposing them in a landfill. And it's a long-lasting product. And another company, Regapol, does a thing where they take tires and they turn it into rubber tiles that are used in gyms and other flooring. It's amazing how we can reuse this stuff. So we're going to have a few minutes here to ask questions before we get into this. I just want to wrap up by saying there is going to be a homework. This was emailed out to you. It's optional, but it's designed to help you to start planning for your data collection process for the LCA or PCF. The link to download this sheet is going to be sent to you along with the recording. So we would ask you to do this. You don't have to turn it in or anything. It's just to help you start thinking about the next thing we're going to talk about next week. We also have a lot of resources. We have a podcast. There's going to be a podcast episode coming out that's going to support all this. We have other resources that you can tap into to help you really guide you on this. And then there's a survey that we're going to be doing. We want you to fill out the survey, because what you fill out this week is going to help us teach you better next week. So really looking forward to having you do that. So next week, we're going to be talking about how to use LCA or PCF results to drive your sustainable product innovation process. We're going to be talking about products and operations. How do you reduce carbon footprint in your operations? How do you reduce carbon footprint in your products? How do you reduce other impacts in your products? So now we're up to questions. Oof, that was a lot. So anyway, it looks like we got about 7 minutes, which is great, so I can answer some questions. And I did want to say also that if you have very specific questions on things I covered here, one of our experts in LCA is Nicole Meyer, and we're giving you her contact information. That'll be in the recording. You can definitely reach out to Nicole. Say you wanted to learn more about how about starting this process or anything like that. Nicole is definitely a great contact for you. So let's come back to questions for a minute, and let me take a look at the question pane here. All right, my question pane has kind of moved. Give me 1 second. All right, so I'm going to start answering some of these questions here. I just got to get my pane back where I can see it disappeared for a second. Sorry about that. All right, so one of the questions I could see is, can you explain how LCAs account for chemical toxicity and potential exposure across the life cycle? And that's a great question. So chemical exposure or toxicity is not often included in the LCA. However, I did show you there are impact categories that we can look at, like in terms of ecotoxicity and things like that. We can measure it with the LCA. However, that we have found that those impact categories are typically more uncertainty in that. However, that is one way to do it. But the other thing you can look at here too is you can definitely use that ecotoxicity, because there's both aquatic and terrestrial ecotoxicity in there. There's also the ability to look at carcinogens and things like that. However, I don't highly recommend you do that. I would recommend you actually analyze products and chemicals based on doing something like following a process of health product declarations or material ingredient reporting, and then taking a look at the actual, all the chemicals that are in there, the different hazards that are associated with them. But don't just make decisions on a hazard, because there's so many things in this world that we use every day that are hazardous, have a hazard of carcinogen, but you know, it's only based on a certain level of exposure or whatever. So you want to also consider risk and the exposure of the products when you're trying to factor that in as well. So we have another question here, and again, I'm not going to answer all these, but I'll do my best. It says, how accurate in general is the data allocation of energy use in the product lifecycle? This seems to be, to me, an area where data could be super hard to gather. Well, it definitely has some challenges, there's no doubt, and that's why we really want to use primary data, and this is why allocation is so important. If we're doing a life cycle assessment on a final product that's being manufactured, we're going to be able to dive into that product, and we're going to actually collect all the data from that plant, right? Energy, water, waste, emissions, etc. And that's going to allow us to then understand, then based on production of all the different products there, how much do we allocate back to that? When it comes to your suppliers, though, that's the reason why the product carbon footprint rules and the EPD rules are requiring good allocation methodologies for suppliers, so then we can get clear data. But if that data is not available and we have to go to a secondary source, that is one thing that brings uncertainty into some of our results. So that's why we do what we call a data quality analysis of secondary sources. We try to pick sources that are the best vintage, like the most recent. We try to pick them that are the most correct to the raw material or chemical or ingredient we're looking at. We look at geographics. We look at different things like that. We then try to sometimes adjust that secondary data set based on the actual location of manufacture, and try to use the actual grid mix for electricity, etc. So those are really important things we have to think about. Another question here, how do you handle lack of eco profiles for specific raw materials? Well, that is a big problem, and that's why you're seeing this big demand now to do product carbon footprints. You're seeing this big demand to do EPDs, and that's why those disclosure mechanisms of product carbon footprints and EPDs are out there. We've had many conversations with manufacturers of raw materials and said, hey, if you have an LCA, we don't want your LCA report, but could you at least give us the output data from your LCA, like a PCF, product carbon footprint, and EPD, or a fact sheet of just the environmental impacts of the functional unit of the material you're selling to us, and we're going to embed that into our LCA. We'd love to do that. So that's definitely something we can look at. Another question we have here is, how can you use LCAs and PCFs to influence final customers' purchase decisions? Oh, that's so great. Well, I think we're going to see a lot of that. And one thing that I mentioned earlier is, if you look at federal purchasing and state purchasing, and even in European Union now, where they're setting global warming potential limits, that is going to drive manufacturers to be thinking about, oh my gosh, if my carbon footprint's above this limit, then I may not get specified or used. It's also going to then get consumers to start thinking about this more. And I think we'll eventually see that starting in the procurement world, but eventually going to consumers in the future. So I know we're coming right up on time here, and I'll see if I have a quick one here. You walk through this rather quickly. Could you restate the main difference between LCA and PCF? So LCA is I'm looking at full life cycle of the product at all the impact categories. So I'm not only looking at global warming potential, but I'm looking at acidification, eutrophication, et cetera. I'm still looking at many of the same things as PCF, but the product carbon footprint is only going to zoom in on the global warming potential or the climate change impacts, the greenhouse gases only. I'm not running those analyses on acidification, eutrophication, ozone depletion. So I know we're at time. Again, if you have any major questions, reach out to Nicole. Thank you all for your participation, interaction. This was really fun and exciting, and look forward to having you all attend webinar number 2 next week. So thank you again. For a lot of these questions, we'll try to respond to some of these questions in our follow-up. Have a great day.